Good morning all. I'd say this is probably the first new bit of algebra in this chapter. We're going to look at how to solve a quadratic when factorising doesn't work. So essentially what we have here is our formula. We are told if we have something that looks like this, where we've got ax squared plus bx plus c is 0, then x is equal to this. And there's a really cool proof of this using something we're going to do in a couple of weeks' time. So I will come back to it and show you, where this has come from at that stage, but we're just going to use it for now. Okay. Now here's an equation that we can already do. Okay, we know if we've got x squared plus 8x plus 12 equals 0, then this is something that we can factorize. It needs to add to 8 and times to 12, and the numbers that do that are 6 and 2, so that can be factorized. And then we set each of those two brackets equal to 0, and we solve them. So we could get that the solutions for this are -6 and -2 using old methods. I wanted to show one that you already knew the answer to, so we could prove that this formula gets the same results, essentially. So, formula talks about A and B and C, and what those essentially are the numbers in front of our letters. So we can see straight away here we've got a 8 in front of our x, and that's apparently what B is. So we've got B is 8. C is the number at the end, so that's going to be our C. And then what about A? Well, we haven't, it's not 0, it is 1, because we've got a single x squared here. So we can start off by saying A is 1, B is 8, and C is 12 on this example. And the signs do matter, so they're all positive 1, positive 8, positive 12. So looking at our formula says that we've got minus b. So let's start writing this down. We should write minus b. So we're going to write -8, because that's what b is. Plus or minus, and I'll come back to what that means in a little bit. The square root of b squared, so that's 8 squared, minus 4ac. So that's -4 times 1 times 12. Remember, if the letters are next to each other, we multiply. And on the bottom, 2a. So 2 times 1. So you're kind of done at that stage, but we need to simplify this and answer normally to a couple decimal places, so we'll do that. So obviously -8 isn't really going to change. We'll just leave that plus or minus in for one more step. And I think the first thing you want to simplify is the answer to what's inside this square root. 8 squared is 64. 4 times 8, 1 times 12 is 48. So we're doing 64 minus 48, that is 16. And then 2 times 1 is just 2. Okay, so what does this plus or minus actually mean? What it means is we're going to get two answers, and we're going to get one answer when we use the plus, and we're going to get one answer when we use the minus. So we have to split this into two possible answers. We're going to get one when we do -8 plus the square root of 16 over 2, and we're going to get another answer when we do -8 minus the square root of 16 over 2. Okay, this can be simplified. The square root of 16, well, that's just 4. So let's write that in instead of the square root of 16. And then think about this. This is a fraction where the top of it is -8 plus 4. That's -4 over 2. So our possible x value there is -2. And with the other one, -8 minus 4, that's -12 over 2. And -12 over 2 is -6. So we get the exact same answers. Now, obviously, in this case, you'd want to factorize. And there's a reason that we don't just do everything with the quadratic formula. But it will always work. So here's one that's a little bit harder to factorize. I'd recommend at any stage you want to have a go, pause it and have a go, but I'm going to crack on. This will actually factorize to 5x and x, certainly. I'm going to use the sort of guess method here. 3 is going to be 3 and 1 of some sort, so I think that's going to be the 3 and that's going to be the 1. And yeah, a little bit of fiddling around should give us that. If you want to expand that out, that should give you the same as what we've got there. So we could solve this with a factorizing method. And we could eventually get from this that x is 1/5 or 0.2, or x is -3. So again, let's show that this works with our formula as well. Let's go a little bit quicker this time. So we can say that A is equal to 5, that B is equal to 14, and C is equal to minus 3. Make sure you take the sign into account. And then we'll put it into the formula. So we're going to have that this is minus 14 plus minus square root of 14 squared. Take 4 times 5 times minus 3. Do not forget that sign. Okay, it makes a huge difference because you're doing a negative times a negative here, and we're going to get a positive there. Anyway, so 2 times 5 on the bottom. A mistake people often make is just always put 2 on the base. They forget about the fact that A sometimes isn't 1. Let's go a few steps further. So we should first work out what's inside that square root, as well as saying the bottom of this is 10. So 14 squared is 196. And then minus 4 times 5 times minus 3 is going to be a plus 60. So we'll end up with 256 inside that square root. Square root of 256, if you're interested, is 16, which means we're going to be able to get some nice numbers out of here. So we'll do this once with the plus, and we'll do this once with the minus, and we'll end up with minus 14 plus 16 over 10, or we'll end up with minus 14 minus 16 over 10. And hopefully you know where these are going. That'll be 2 over 10, which is 1/5, which is the same as the answer we got using our good old-fashioned factorizing. And the other one would be minus 30 over 10, which would simplify to minus 3, which is the same as the other answer that we got. So yeah, method works. But why does it exist then if we've already got this factorizing? So the problem is that some quadratics are awkward and won't factorize nicely. Let's look at this first one as an example. Okay, this has got a single x squared, so and it's got a single x and it's got a minus 8. So we'd be saying, okay, well, we want to add to the middle number, we want to add to 1. Remember, if there's just x on its own, it means it's 1. And we want to times just to minus 8, just a number at the end. Are there any numbers that do that? Well, what times is 2? 8. 1 and 8 and 2 and 4, and that's it really in terms of whole numbers. And there's no combination of those numbers, plus or minus, that will add to 1. 4 minus 2 is 2, is about the closest you can get. So what we need, and what the formula's for, is a more systematic approach. It allows us to always get towards an answer, even if it's unpleasant. So let's put those 1s in, because I think that's useful to consider. This will give us that A is 1, B is 1, and C is minus 8. A is the number of x squared, B is the number of x's, and C is the other number. Put that into our formula. So our formula goes minus B, so that's minus 1, plus or minus square root of b squared, so that's 1 squared, minus 4 times a times c, and remember c is minus 8, all over 2a, so all over 2 times 1. You do have to learn this formula at some stage. It's not given to you in the GCSE. It used to be, not anymore. Anyway, let's carry on. So we probably want to work out what that square root is worth. 1 squared is 1, minus 4 times 1 times minus 8 is 32. And we're doing bid mass, so we are doing the timeses before we do the add. Minus times minus gives us a plus, so we'll end up with that square root being 33. So x is equal to minus 1 plus or minus the square root of 33 all over 2. So we do it once with the positive and once with the negative, and we'll end up with x is minus 1 plus the square root of 33 over 2, which if it said actually give your answer in exact form, that's as far as you can go, but we are going to look at decimals as well. And if you type that in, you should get yourself to roughly 2.37, be good to check. And for the other one, we want to do minus 1 minus the square root of 33. Let's write that a little bit better. All over 2. And that would give me an x value of minus 3.37. So those are my answers. Now, if we think about like what would that factorize to, remember obviously the sign changes when we take them out there. It would be something like x minus 2.37, x plus 3.37. is equal to 0 would have been the correct way to factorize that, and yes, those numbers do add up to 1 and they do times to minus 8 or close enough with some rounding, but We're never going to spot those in a million years. That's what the formula's for. Makes your life easier. Okay, this second example I've put because there's one more common mistake people make, as well as getting sort of these signs wrong in the 4AC bit. So here we've got A is 3, B is -5, and C is 1. That bit is okay, hopefully. So let's put them into the formula. Minus B. So B is negative this time. So minus B is going to be positive. Minus minus is a plus. That's one of the mistakes. The other one is this. We are squaring -5. We're not squaring 5 and sticking a minus on it. We're squaring -5. And a minus times a minus gives you a positive result. The square of -5 is positive 25. That is where nearly all mistakes with the quadratic formula come from. People write in -25 for that. Anyway, let's carry on. So that's b squared minus 4 times a times c all over 2a. Okay, so 5 plus or minus, and let's work out what this was. So 25 minus 12, that'd be 13 for that square root, wouldn't it? Yeah. So 5 plus or minus square root of 13 over 6, and then we do that once with a plus and once with a minus. So one possible answer would be 5 plus root 13 over 6, and one possible answer would be 5 minus root 13 over 6. Let's just type them in. And we should get from that, if we wanted to put those as decimals, that x is 1.43 or it's 0.23. Yeah, never going to see those ourselves, are we? But yeah, really powerful little method here. I'm going to look at a couple of different ways you can use it, but that's the basic idea now. So another important point, and this was true for the factorizing as well, is that for this to work requires one side of the equation to be 0. We explained that in the factorizing as in we needed two numbers to times to 0, so we could say that one of them had to be 0. This has a similar sort of reason, but again we'd need to look at the proof, the quadratic formula, for me to give more reasons than that. For now it's just enough to know one side has to be 0. So let's look at these as an example of what you'd do. We've got 2x squared plus 13x plus 3 is 9x plus 6. So what we need to do is we need to make the right hand side a 0. So we'll take away 6 from both sides, and we'll take away 9x from both sides. And you can do that in more steps than I am if you want. 2x squared plus 4x minus 3 is 0. Okay, so that gives us that a is 2, b is 4, and c is minus 3. So let's put those all into our formula. We'll end up with x is minus b, so minus 4, plus minus square root of 4 squared minus 4 times 2 times minus 3 all over 2 times 2. Again, well worth working out this bit in the square root first. 4 squared is 16. Minus 4 times 2 times minus 3 is plus 24, because minus times a minus. So that would be 40 inside the square root. So x is equal to minus 4 plus or minus square root of 40 over 4. And that would give us final answers of 0.58 and minus 2.58. Now there's a little bit of a debate in terms of how much working you do need to show. In my opinion, what I would expect to see is certainly this line and something approximating this bit where you work out what the square root is worth. I think that's all I really need to see as far as stuff being written down, and certainly all the examiner needs to see. These questions are generally worth 3 or 4 marks, so you don't want to go straight to the answers because you're going very hit or miss at that stage. Okay, I'd like you to pause at this go, have a go at this example, and then I will come back in 3, 2, 1. Okay, so if we're doing this, we want to make one side 0, obviously. We're also going to need to expand these brackets because we can't really subtract from brackets. So let's do that. 2x squared minus 6x plus 5x minus 15 is x squared plus 17. Next thing we'd want to do is we'd want to subtract from both sides. So I'm going to take away x squared from both sides, and I'm going to take away 17 from both sides. So that'll give me x squared minus 6x and 5x, that's overall minus x, and minus 15 minus 17, that's minus 32, is 0. So we can go into a formula, we can use x is one, a is 1, we can use b is minus 1, and remember that sign makes a big difference, and c is minus 32. So plug them into the formula, minus b, so remember, because b is minus b is positive, so that's 1, plus or minus the square root of. Now remember, we're squaring a negative, so it's going to be positive, or if you want to put it in your calculator, you need to put a bracket around the minus sign for your calculator to recognize that. Minus 4 times 1 times minus 32, all over 2 times 1. Can we simplify that? Yeah, a little bit, so let's work out. That's minus 1 squared is 1, positive 1. 4 times 1 times minus 32 is going to give us plus 128, so that's going to give us 129 in the square root, all over 2, and let's just type them in. Should get 6.18 and minus 5.18 as your answers. Now another thing you could ask yourself is, well, how do I check if these are right? And you can sort of take those numbers and plug them back into the original equation and see if it works. But just bear in mind, you will have some rounding errors if you use the decimal ones, so you might end up showing that like 0.3 is equal to 0.2 or something, but they should be close enough. So if you do need to check, that's your method, but you've really got to trust the process, and that's why showing, as I said, these two steps here is really important for getting the marks you deserve. So is there anything to watch out for with a quadratic formula then, apart from just like sign errors? Well, there is the fact that it doesn't actually always get you an answer. Okay, so this is an example where it doesn't work. X squared plus 4x plus 9. A is 1, B is 4, C is 9. And then we want to put that into our formula, so x is minus b plus or minus the square root of b squared, so 4 squared minus 4 times a times c, all over 2a. If we try and simplify that square root, 4 squared is 16. This is minus 4 times 1 times 9, so it's minus 36. So the value of that square root is minus 20. And then the bottom of that is 2. If you try and type that into your calculator, you will get something that says something like math error. And the reason for that is because you're trying to square root a negative number. So square roots of negatives don't actually exist, because if you think about it, a square root is saying I times it by myself and I get this answer. If we think of something that would times to a negative, either it's positive, and a positive times a positive is positive, so that can't be right, or it's negative, and a negative times a negative is positive, so that can't be right either. So there is no number that you can times by itself and it will give you a negative result. So we can say that square roots of negatives don't exist. So we end up with an error there. And again, that's where we have to trust the system. You might sometimes get math errors just because you type stuff in wrong. If it's an exam question, I would normally expect there to be an answer. But if we're getting up towards the grade 8 and 9 style of things, there is a little bit of an appreciation that sometimes this formula doesn't work. And that's not actually a fault of the formula. That's the fact that some quadratics don't have a solution. Just as, I suppose there's some linear equations that don't have a solution as well. If I was to say something like 2x plus 1 equals 2x plus 7, well, I could take away 2x from each side, and I could end up with, and I could maybe take away 1 from each side, and I could end up with something that said that 0 equals 6, and that clearly doesn't have an answer. There is no solution to this equation, and it's the same with this quadratic. It's just harder to sort of see when there's squares involved. There is no set of x's that will work, and that's how we find out. I'd like to try the second one and show there's a problem with it. I'm coming back in 3, 2, 1. Okay, so we'd say a is 3, b is minus 1, c is 7. We put this into our equation. Minus b is 1, minus 1 squared, minus 4 times 3 times 7, all over 2a. That would give us what's that square root worth? 1 minus 84, so it's equal to minus 83. And you can see again, don't forget my minus sign there, you can see again we've got our negative number inside our square root, so there are no solutions there either. So yeah, just be wary that it won't always work, but if it doesn't work, that means there aren't any solutions at all. Okay, I thought we'd look at a few awkward questions to sort of finish this off. Your classwork does have some of these in, so it's well worth watching through if you're getting a little bit stuck. But feel free to try them first if you want. Okay, let's crack on. So our first one, we have got, I'm going to put some brackets around these, kind of like a linear equation. So when we've got something on the bottom of a fraction, we want to multiply the other side by it. So our first step here would simply be multiply across by m plus 9. What would you do then? You'd want to expand your brackets. So we'd end up with m squared plus 10m plus 9m plus 90. And then we probably want to subtract the 7 from both sides as well. So if we did that, we'd end up with 0 is m squared plus 19m, let's bring them together, plus 83. Then we could plug it into the formula. And I'm not going to go through that whole process. You've seen me work through the quadratic formula enough at this stage. So I'll just tell you that the two answers you should end up with are minus 6.81 and minus 12.19 if you wanted to check that yourself. What about the second question? The triangle has an area of 19. Well, we know how to find the area of a triangle. It's a half times base times height. And we've got the base is x plus 6, and we've got the height is x plus 5. So it's just going to be a case of writing that down. A half times the base times the height is equal to 19. What should we do with that? I would probably double both sides. I don't like that half. So x plus 6 times x plus 5 is equal to 38. Then what would we do? Well, we'd expand the bracket. So we get to x squared plus 11x plus 30. When you fully expand that, is 38. And then we'd subtract our 38 from both sides. So we'd end up with x squared plus 11x minus 8 is equal to 0. And then again, I'm not going to go through the whole process here. Obviously, we'd be saying that a is equal to 1, b is 11, and c is minus 8. But I just want to say one last thing on the answer here, which is that you'd end up with two possible answers. We could have x is 0.68 or x is minus 11.68. And we only want to pick one of them. Now again, this is the thing where sides of shapes have to be positive. You can't have a negative length. So this is our answer, and that we'd have to say can't be a correct solution. There we go. Okay, two last awkward questions to consider. Again, I'll sort of give you the hint of what you need to do without working through the whole thing. This is an interesting question on the left. It says, we've ended up with this value. What was the original equation? Now, what we're essentially doing is we're comparing those bits and pieces to the formula that came up with it. So let's do some color coding. This 3-bit here must be the same as, let's draw that a bit tighter, must be the same as this minus b here. Okay, so we can say that minus b equals 3. Okay, what else have we got? Well, we've got this root 29 thing, must be equal to this square root here. And we can kind of just ignore the square root part and say from that that 29, ooh, that's not a good color, I can't see that at all. Let's write it in green. 29 is equal to b squared minus 4ac. Sorry, yellow, you tried your best. And then we've got one more. On the bottom, we've got 2, which is equivalent to this 2a. So we can say that 2a is equal to 2. Okay, what's the value of doing that? Well, it means we can work some stuff out. We can certainly work out from this that b is minus 3. We can certainly work out from this that a is equal to 1. And we can take those values and we can put them in the other equation. So if you put that all together, we'll end up with 29 is b squared, so that's 9. Remember, negative times negative is positive, minus 4 times a, which is 1, times c. So we'll end up with 29 is 9 minus 4c, and then we've got a linear equation we can solve. Let's take away 9. 20 equals minus 4c, and let's divide by minus 4. Minus 5 equals c. So there's our three things. So our original equation, because remember they have to look like this, ax squared plus bx plus c, was 1x squared plus, minus even, minus 3x, and then minus 5 equals 0, was what we started with there. So yeah, I think that's an interesting one. And then we got our last one, which is a Pythagoras question. Generally, GCSE loves to put Pythagoras into questions where it's not the sole focus of the question. How do I know it's Pythagoras? It's right-angled and it talks about the sides of the shape. There's nothing really else you can do with that. It doesn't talk about the area, it doesn't talk about volumes or anything. It's got to be Pythagoras. So it says to find x. And again, I'm not going to work through the whole thing, but let's talk about what we should do. Pythagoras' formula is that the side squared plus the side squared is equal to the hypotenuse squared. The hypotenuse is the longest side, it's also opposite the right angle. There's our hype. So what we're saying here is that x plus 1 squared plus x plus 2 squared is equal to 2x minus 5 squared. Now, potential problems you might have with this, I think some people might want to square root it all at once, and that doesn't work because you're square rooting two separate squares, which is not allowed. So what we actually have to do is expand all of these brackets. So we'd have to go and write them out properly. If we've got an x plus 1 and an x squared, that means there's two x plus 1 brackets. And the same would be true for all of these. So we would have to expand this all out. So let's do that quickly. Again, you probably want to use a little bit more lines than I'm using, but I'm conscious of time. And then what would you do? You'd have to subtract everything to one side. So we would subtract 2x squared, and that would sort of get rid of these two here. And then we'd subtract a total of 6x, which would take us down to minus 26x, and that would get rid of those. And then we'd subtract 5, which would take us down to plus 20, which would get rid of those. And so we'd end up with a quadratic formula we can solve. Something that's worth pointing out with any quadratic formula, you can multiply it, divide it by anything you like, and it'll still have the same answers. So here is a good scenario where I would divide everything by 2. I would say 0 is x squared minus 13x plus 10. And then I'd solve that using the formula with a equals 1, b equals minus 13, and c equals 10. Again, not going to show it in full, but you should end up with x is equal to 12.18, or x is 0.82. Now again, you have to think about this as a shape. Are any of those not possible? And they're both positive, so that looks okay. But if you substitute this into the hypotenuse, which is 2x minus 5, you actually get a negative result. So it ends up being that that can't be right, and this is the right answer. Okay, so that's the quadratic formula, and that's a few interesting uses of it. Best of luck.